you really want it, don't hesitate. You came this far, now finish out the whole dream. Nobody said it would be easy though. Just stick to your plan. They don't understand. Going up against the odds, having no regards.
As we thought back to the first day of class, one thing that stood out the most was Domino Lincoln.
Wow, that's amazing. It's so beautifully optimized.
We're gonna have to code that? I couldn't even code in BBA.
Yeah, that's a joke. I'm sure we can make you look even better.
We began to dream of a world where optimized domino art would be put on the wall with the other masterpieces of the Memorial Union. With this dream in mind, we set off to write code to make beautiful domino artwork. To make this dream a reality, we started off on our mission. The mission to make Wiz Khalifa's face out of a limited set of dominoes. To do this, we needed to use the optimization techniques that we have learned in class, as well as coding techniques from classes such as IE 148.
Here we have our LP model. At the top of the page we have our zeta that we are hoping to minimize. The Xij represents the intensity value matrix of our original photo. Yij is the intensity value matrix of our domino photo. We hope to minimize the difference between these two matrices in the hopes that we get our domino photo as close to the original as possible. There are several constraints that must be taken into consideration given we only have 30 sets of dominoes. There are 2 sets of 10 variables representing the intensity measurements 0 through 9, 0 being black and 9 being white. The uppercase X variables are limited to be less than 330 because that is the total number of each type of pip, 0 through 9, in our 30 sets of dominoes. The lowercase variables are binary variables that are there to limit the number of dominoes in each cell of the matrix to be 1, meaning you can only have one picture in each cell. Step 1 in our process is to import the image into MATLAB. We do this by using the imread function as you can see on the code below. We use the imread function to import the WizJPEG, and then we use that same variable to imresize or resize the image. We set it to 60 by 55, that way it better fits our matrices. Step 2 in our process is to convert our original image to a gray image. We do this by using the RGB to gray function in MATLAB. It takes the red, green, blue image and converts it to gray monochromatic. And then, once we've completed that, we use the gray to end function in MATLAB to measure the intensity values of the black and white image. Step 3 is importing the dominoes. Again, we're using the imread function to import the images of the dominoes, and the RGB to gray to convert the images to a monochromatic gray color. We then create a Y matrix and then make it an empty matrix, that way we can import images into it later. Here we have the main loop of our code. It goes through a for loop, and then another for loop, and then a few if statements. The first loop goes through all the columns in our matrix, and then the J loop goes through all the rows in our matrix. It then uses if statements to judge what the value of that cell is. It goes through the first X matrix to see what the intensity values of the first picture is. And then it replaces it with the corresponding domino picture. Step 4 in our process is compiling all the dominoes into the final matrix. Using the cell to map function, we create the matrix that will contain our final image. And then, using the imshow function, the image is generated and finally shown to us at the end of the code.
At last, the moment we've all been waiting for, where we get to see our final image. As you can tell, it looks just about perfect, looking nearly identical to the original photo. Thus, we will name our masterpiece, Pure Beauty.
Now that we've finally gotten our perfect photo to generate, we move on to incorporating constraints. So we go to step 5. With a limitation of 30 sets of dominoes, it's inevitable for our program to run out of specific pieces. So to represent this, we hard-coded a method of replacement to replace exhausted pieces with similar ones. We did this by a series of if loops. As you can see, the photo to the right is not the exact same as the one in the previous slide, but it's pretty close to the same contrast. An example of how these if loops work is if we run out of 8s per se, it would test whether we could use 9s. And then, if we couldn't use a 9, it would go down and try and use a 7, because they're pretty similar in contrast.
Yeah.